Oh, this is Charlie. Welcome to Introduction to Computing. Uh, Let me share my screen and we can get started, okay? Uh, so a little bit about myself. I've been lecturing this course for several years now. I also lecture the malware analysis course, violent Python course, computationally thinking, and this semester I'm also lecturing the C programming course. I have a PhD in cyber operations, and my research area was in the Mirai botnet. That's an Internet of Things botnet. So what I wanted to do is let's go through the syllabus, make sure we understand. Okay. So yeah, that's me, the instructor, Charlie Frank. Call me Charlie. I provided my phone number. That's my cell phone. Text me. I'll get back to you. If you have any questions, of course, you can also send me an email. Um, Here's the course homepage. Um, Course dates are from the 14th at 1:14 to 5:14. Uh, they'll occur every Monday, 8 to 10 p.m. Eastern Standard Time. I live in the Poconos of Pennsylvania, so I know Eastern Standard Time. I get confused between all the different time zones. So you'll have to convert it to your time zone, wherever you are. So course objectives, we'll skip through that. We're going to get to all those objectives as we go along in the course. Outcome, same thing. Okay, text. I think it's you definitely the text is provided for free and the homework problems will come from the text. So you'll need to be able to access the text. Now, there will be weekly assignments, homework assignments, there'll be discussions, and there'll be quizzes, okay? Okay, comprise the true or false. There, we're talking about the assignments. There'll be a mix of short answers and longer answers, and it'll be based upon the lecture and what's in the book. And then there are discussion posts. You will have to every week initiate a discussion post and reply to two other topic threads, okay? And of course, there's a final exam, which will be a subset of questions from the quizzes. Typical grading stuff, A, B, C, D, E, right? And I think for the quizzes, this is important. The quizzes, you'll be able to get 2 attempts per quiz. So if you take the quiz the first time, you didn't do so well, maybe you study a little more. Yeah, so and then you take the quiz the second time. So the important part is going through the quiz for the first time. Remember the questions that you struggled to answer so that you can go back and find the answers in the book and understand those concepts better before you take the quiz again. I guess that's the trick, okay? Most folks do very good on the quizzes in this class and on the assignments and the work. So, of course, there is a final exam. It's based upon the quizzes. Okay, so I's and W's. And here's a schedule. The introduction to tonight will be module one, data storage. Now, a little bit about the assignments. I don't deduct for being late on assignments. I do that for several reasons. Number one, maybe you need more time to review the material. Number two, sometimes life gets in the way during the semester. I mean, students I've had children over the years during the semester, or they had to go away. They're in the military and they had to go away for the military for a few weeks or whatever the case is. So try to keep up. An assignment is basically due the following 2 weeks. Okay. Try to stick to that schedule if you can. But if you can't, that's okay. If it takes you an extra week or 2 weeks or 3 weeks, whatever, if you complete with assignment, that's okay. But get them all in before the semester's over. If you do not, then I'll have to give you an incomplete. And I don't want to do that. I don't want to give out incompletes if I don't have to, because generally speaking, for a lot of students, when they get an incomplete and they say, well, I'll finish and you have a year to finish the course, they will I'm not sure if they'll finish the course because then next semester they're taking other classes, life gets in the way, and then they don't wind up finishing the course in a year and then they have to take it over again. I've had a few students, not in this course, but in my malware course that have done that. So I don't want you to do that, okay? So, because I want you to go on from this class and take a bunch of other classes and not have to worry about this class. So if during the semester that you think you're in jeopardy of finishing this course, please send me an email as soon as possible. If you think that you won't be able to hand in a few assignments to a later point in time, just drop me an email, make me aware of it. I'm fine with that. I just want to make sure that you complete the course, okay? So let's go. Oh, and one last thing that's not mentioned in the syllabus. I encourage the use of ChatGPT and generative AI in general. It could be Claude or whatever, right? So to help you understand the material, even maybe come up with some answers in the homeworks. And I'll show how to use it when I go over the homework. I go over the homework every lecture. So let's go here. Okay. So module one introduction. Let's make sure I covered the okay. The introduction's in here. So there's a self-introduction. Make sure that you post on there, okay? And there's a syllabus quiz. Make sure you take it. Uh, reading material. Okay, so you have a choice of the two books. They're free. Just click on the links and you should access the book so it won't cost you anything for the book, which is nice. It's probably a good idea to save the book, save the PDF document, to be honest with you. It just saves you money. The book is pretty good introduction to computer science. Okay, so we did the introduction. So we're on module one, data storage, right? So again, you'll have to complete a quiz. You'll have to submit assignment. Hopefully you complete that assignment by the time of the next lecture, module two, right? Because we're in module one. Make sure that you read chapter one. It's good if you can read the chapter before the lectures and then maybe review the chapter after the lectures quickly, and that'll ingrain in your mind all the material. And this is on data storage. So there's assignment, a quiz, and a discussion. Okay. So let's go to the lecture, the actual PDF. I should have this here. Here it is. Okay, bear with me. Okay, so let's go in the beginning here. So here we're at chapter one of the book. There's a nice cover of the book. Oh, and another thing too, I'm a very casual person, so if you're on the lecture and you have a question about something, feel free to just chime in and interrupt me. Okay? No problem. If you're listening to the lecture, then if you have a question, text me or email me. I'll get back to you. Okay. So this is chapter one. This is about bits and their storage, main memory, mass storage, representing information as bits and the binary systems, right? The binary system 0, 1. So data and integers, storing integers, fractions, data and programming, a little bit of that, data compression and communication errors. Uh, oh, and another thing too about this course is that students tend to struggle maybe the first month in this course with data storage and more computer architecture type stuff. And the second, but in 2 weeks, we'll be covering machine learning, not machine learning, assembly and machine code. And they struggle a little bit about with that, okay? But then the remaining topics, they tend to do very well. So if you're struggling in the beginning, give it your best shot. I guarantee it's going to get easier for you as you move as we move along in the course. So don't stress out in this beginning material. This is the first month is the hardest part of this course. Okay, the bits in their storage. Binary bit is 0 and 1. Everything that's represented is a 0 and 1, right? Bit patterns are used to represent numbers, characters, images, sounds, and other things, okay? Boolean expressions, right? These are things like and, or, exclusive or, not. They're just Boolean expressions. So we're going to tie this all together in a few moments. So we just want to let's review some of the Boolean expressions, like the and, as you can see here. And if both are a zero, then it's a zero. If one bit is a zero, one bit's a one, then it's a zero. And you get it so forth, right? And then the or is either bit is one, then the result is one, okay? They all have to be they both have to be zero to be a zero. Exclusive or, okay? Exclusive or is an operation that uh both the zeros, they're zeros. Only one, so the key here is exclusive or only one bit could have a one. If both bits are a one, then it's a zero for the result, okay? So I don't know if this is review for folks. Hopefully it is. I'm hoping it is. If not, that's okay. A gate, it's a device that computes a Boolean operation, right? It's contained in electronic circuits called transistors. Can be constructed from a variety of other technologies, right? So we'll show you. I remember building a Coke machine from all different kind of gates when I had computer architecture back in the day. Okay, so when we describe these gates, we draw them, and this is the pictorials of them. So there's the and. This is what on the left. Here's what the and looks like, and here's a table for the and. So if they're both zero and zero, return zero, right? A zero and a one return zero. So the inputs are on the left, and the output is on the right. And you can just look at that table. Now, if you see there's a difference with the or. Uh, for example, the second row in this table with an or, if it's a zero or a one, then it's a one. But with the and, if it was a zero or a one, it's a zero, right? So there's the difference. And now here's the exclusive or. Again, the exclusive or is one of the inputs can only be one. And if it is, then the output is one. Otherwise, it's zero. And there's a not. So simply put is if you take an input of zero and you have this triangle with a circle that represents the not, then it'll be one. So zero, the output is one. So it's the reverse of the bit. It's what the bit isn't, okay? Flip-flops. Circuits built from gates that act as a fundamental unit of computer memory, right? So one input line is used to set its store value to one. The output line is used to set its value to zero, right? So and with both input lines as zero, the most recently stored value is preserved. Now I must be honest with you that we're going over this material. How often will you use this after this course? I know that all my years in, I guess it depends on your position in an organization, but most likely you won't, unless you're working for some chip manufacturer. And I still don't think you would be doing this because I think it's more of an engineering degree than like a computer science or information systems degree. But it's good to know this. It gives you the background. But other than that, I'm being honest with you, I don't think you're going to use this material anywhere else. I know I didn't for 35 years, so I don't think you will. But so we must learn it anyway, so it's a requirement of the course. So a simple flip-flop circuit here is showing input to the OR gate, input to the NOT gate, and then the output. And what you do is simply you follow the lines, okay? And we're gonna have an example in a minute. First, a one is placed in the upper input. So one, there's an input of one, okay? This causes the output of the OR gate to be one because it's an OR gate. So no matter what that input is to this OR, not, yeah, the OR, that's OR symbol, the output has to be one. So then you go back through and there would be one here, one there, right? And since it's zero, it's one. It has to be a zero, right? Because it's and. The only way to get a one, right? It's a zero. So finally, one for it keeps the OR gate from changing the upper limit to its. Uh, so I think they chose. Okay, zero changes. Okay, the one. Finally, the one from the AND gate keeps the OR gate from changing at the upper limit returns to zero. Okay, a little confusing. You have to really work through it. Another way of constructing it, which may be even there's the input. Uh, goes the output. I think this is good. The input, the or, not, and you follow these lines, okay? It can be a little confusing. It's probably a little confusing to you when we explain this. You got to really try to work on it, okay? There's no other way just to work on them, and we will have homework uh, questions based upon this. And so, okay. Hexadecimal notation, a shorthand notation for long bit patterns, okay? So there is divides a pattern in groups of 4 bits. We divide into 4 bits, okay? And so this becomes 0 hex B5. Why is that? So maybe I could do this. Okay, I have I have for the other class, the debugger information. Let me do this. That's not for our class. Okay, so we could do this. Just 1, 2, 3, 4. We split this up. Okay, the 4 bits. Now, the way the bits work is you start left, you start right to left. So 1, then 2, then 4, then 8, right? So in this case, and why is that? Because that would equal 3, 7, 15, 12, 13, 14, 15. So the one there is 1, 2, 4. That's a 5. So that part is a 5, right? And if you do this over here, do this one, that's 1, 2, that's 3, that's 11. Now, when hex, we only go to 9, and then 10, 10 is an A, 10 is an A, 11 is a B. So that's how they came out with 0 hex, that stands for hex, and this is B5, okay? That's how they come up with B5. And let's see if I got this right. I hope I did. There you go. And that's how it came up with hex B5. 0x stands for hex, okay? Okay, and here is what I was talking about. Here's the hexadecimal coding system, right? As you can see, once we get to 10, then it's an A, B is 11, C is 12, D is 13, E is 14, and F is 15. Okay? So I explained how that would work. Okay? Main memory. Okay, I think we all have an idea of what main memory is from using computers, right? Hopefully. It's a unit cell. It's a unit of main memory. You typically 8 bits, which is 1 byte. A byte is 8 bits. Most significant bit. The bit at the left is high order. Least significant bit at the right is low order. Okay, that's what we're using for this course. So the organization of byte-sized memory cell. Least significant, most significant, they're showing this, the least and most significant. Okay, both 0 in this case. Address, a name that it uniquely identifies a cell in the computer's main memory, right? They're actually numbers. So here's an example of memory: cell 0, cell 1, cell 2, cell 3, cell 4, cell 5. Okay. And it looks like that's the contents, is what's inside the cell. Okay. Random
Uh,
access memory. Yes. Hello?
um, Hello.
Yes.
Can you hear me, sir?
Yes, I can hear you, David.
Okay. I just wanted to clarify that is it every time that we want to represent the hexadecimal that we should put the 0x in front of the
Yeah, you could do that, or
solution?
just 0x or x. Okay. I think
Oh,
it's good
okay.
to do. I think it's good to do 0x. But if I see an x, I know what you're talking about. Okay. And like I
Oh,
said,
okay.
hex, you may, it all depends on what you're going to take in college and major in, whether this is even important. Uh, I reverse malware. I do a disassembly, so it's a little bit important. But if you're not going to do that, let's say if you're going to uh, secure clouds, for example, I don't know, or be a C programmer or Python programmer, something like that, may not be as important, being honest with you. So it all depends. I have to be honest about all this material. Some of the other topics will be much more interesting than this. So, anyways, I was here. Thank you for the question.
Thank you,
So,
sir.
yeah, you're more than welcome. So, random access memory. Memory in which individual cells can be easily accessed in any order. There's random, and there's dynamic memory, RAM, composed of volatile memory, right? So the memory doesn't last. So here we're talking about measurements of kilobytes. It's 2 to the 10 bytes, or 1,024 bytes, right? 3K is 3 times 1,024. Megabytes is 2 to the 20 bytes, or 1,048, 576 bytes. And the reason why we're going to have to know this for this course, we're going to have a few questions that are going to involve storage, and we're going to give the answers in megabytes, for example, okay? Or kilobytes or gigabytes. So it's just to understand the measurement. So 2 to the 30th bytes, 3 gigabytes is 3 times 1,744 bytes. Okay, they're just calculations. You have to know them. Okay, mass storage. There's all kinds of devices for storage, right? Discs, CDs, DVDs. I don't think people use CDs anymore, right? Magnetic tapes. Sometimes data centers use them. Flash drives, I think they use more solid state drives. Advantage over main memory, the less volatility, larger storage capacities, right? Low cost, especially believe it or not, the magnetic tape is low cost, but and in many cases it can be removed. But there's always trade-offs between all these different types of storage, and I don't think I think we may go into some of them, but to go into all these would take us too long to really analyze it all. But so those are the type of storage, right? Bandwidth, the total amount of bits that can be transferred in a unit of time. And latency, the total time between the request for data and its arrival. Okay, so either the bandwidth, how much data you can transfer, and the time, latency, the time between its transfer and its arrival. Okay, another thing about this course, this is an introductory course, so a lot of these topics that we're going to be covering could be courses in themselves. So we're covering them at a very high level. Like for example, later on the course, we're going to have a topic in operating systems. Now that in some universities is two courses, operating systems one and operating systems two. So you get the idea. So this is at a very high level, and you may have more questions after I present this material and wonder. So, and I don't mind if after presenting this material, maybe you could send me an email or something if you have a question about a topic that I covered, uh, additional questions about it, and I'll try to answer them. Okay. But I also wouldn't kill myself going too deep into any one of these topics. It's just too much. It's like I said, we're covering a lot of different topics here and there. They're meant to be at a high level. Okay. A magnetic disk storage system. Okay, so the disk motion is turning counterclockwise. You have an arm which reads the data. It's a read-write data. You have the disk and track. Okay, so you think the tracks. So you have tracks running around, right? So you have one there, one there, one there. It's keeps going around and around. You have a whole bunch of them, and then they're divided into sectors. Let's see if we got a better picture of this. Okay, here it is. What I was trying to describe, right? So data recorded on a single track consists of individual sectors that spiral toward the outer edge, right? So I think of this as I don't know if anybody here has ever run track and field. I think of it as all the different lanes in a running competition around the football field, right? The track and field, and that's what you think of. I think of them as, right? And then the sectors are each unit of them it's splitting up, it's chunking up each track. Flash drives. Okay, I think we understand flash drives more. Circuits that traps electrons in tiny silicone chambers, right? Uh, re repeated erasing slowly damage so you die. You if you they have a life, expectancy on them. Mass storage choice for digital cameras, smartphones, SD cards provide gigabytes of storage. right? So, but there's also being an information security guy. You also got to be very careful with these flash drives when you plug them in. Uh, or flash memory. When you take a flash drive and you put it in to your computer, USB. I'm talking about a USB device. When you put a USB device in, better make sure you know where it came from, that it's secure, right? Represented as a bit. Many different kinds of information can be encoded as bits. You better believe it. Everything gets encoded as bits in the computer, right? So text, data, numeric data, images, sound, and everything else. It all comes down to zeros and ones. So each character is letter, etc., is assigned a unique bit pattern, ASCII. It uses patterns of 7 bits to represent the most symbols in the English text. ISO. It's a number of 8-bit extensions to ASCII, each designed to accommodate a major language group, right? So that's why they came up ISO. And then Unicode uses patterns up to 21 bits to represent the symbols used in languages worldwide. 16 bits for world's commonly used language. Because I think the reason why they had to do that, because the English language, I don't know how many alphabetical characters we contain. Was it 28, 27, or something like that, right? But there's a lot of other languages like that contain a lot more to communicate. So they had to come up with these standards. That's all you really need to know. Oh, we'll have a question on ASCII for the homework. So. And you can find on the internet, you can find ASCII tables to convert letters to the actual bit coding, because you'll be asked that in the homework. Okay, so here they're doing it. Okay, so hello in ASCII. So there was a table that's 0001000, that the HELLO. Okay, and then there's a period. It also has a bit encoding. Okay, so I think there's a table in the book. Of course, you could always just search for it here. And this is what they're talking about. You probably look in the dependency of the books. I'm pretty sure there is. So here's the ASCII table, right? So therefore, the letter A is 41 hex and a 65 decimal. Okay, so that's what they're doing there. They're mapping to hex. Okay. Well, they're not doing hex. They're actually giving the bit representation, which you should be able to do now that I showed you how bits are represented in hex. So you can take the hex value and then break it down into the bits. Okay. Okay, let's go back here. And that's going to be in the homework assignment. Okay, I think this is right here. Okay, so your binary notation uses bits to represent a number in base 2. Okay, all values of repeat are stored in sequences of zeros and one, numeric values. Counting from 0 to 8. Right? Again, I explained this, right? 000. 1 is 001 because the rightmost bit is 1. 0010 is 2 because the second bit is a 2. And 0011 is 3 because that's 1 and 2 is 3, and so forth. This is what I explained earlier. So that's how it gets represented into the bits. Representing images, bitmap techniques, picture element represents one dot, right? Red, green, blue. Luminance and chromiance, problems with scaling up images, right? So, and then there are vector techniques, represent images with geometric structures, scalable, true type, and PostScript. I don't think we're going to do anything. Any questions are going to be asked about it on the homework about images. Okay, I don't know about the quiz that has images or not, but it's very basic here. You please review the chapter in the book. So here, a record actual audio, long distance telephone, 8,000 samples per second. CD sound, 44,000, a little bit over 44,000 samples per second. MIDI stores directions for making sound using music synthesizers. It's a standard, right? And an instrument note and duration. Okay, the sound wave represented by the sequence. So there's a sound wave by the sequence of values here. And that's another thing I do when I lecture in these, especially for this first month. I'm going to indicate to you, and you're going to see from the homework what you need to know. And then I'm very focused on that. I just want to get you the material that you need to know, and I don't want to have you waste time on material that you don't need to know for the quizzes and the tests. But of course, be my guest to read up on it if you're interested in it. So if I go over something quickly, it's probably not important for us in terms of a test or a quiz or a homework problem. Okay? The
Hello,
traditional
Professor.
decimal, yes.
So, will a lot of the quiz questions be on the test?
Yes, the test, the final is made up from the quiz questions. It'll be the same as the quiz.
Okay, okay, okay. Thank you, sir.
Yes, and so last year, so this is only the second year we're doing that. We used to, you guys are lucky. We used to, which I didn't like, we used to have a team project in this course, and that was a pain in the neck, okay? And we used to have to do some research and make a poster of the software system that we're intending to write and so forth. And so we did away with that because there's a lot of issues doing team projects when everybody's located around the world and different time zones and get together to do it. And then so what I was doing in the course for a couple of years is I was telling folks if you can't do it in team, do it single. And then the university decided to just give a test instead. It was just easier for the students. Now we're going to cover software engineering, which, be honest with you, I have issues with. When we get to there, you're gonna understand my opinion of software engineering from a cybersecurity perspective. Uh, but anyway, and I'll give you my opinion about some of these subjects. Uh, and like I said, this kind of stuff, just going over bits, is kind of boring. So I'll just try to hang in there. I'm getting bored myself, be honest with you. So I don't know if anybody in the call is anybody in the call finding this interesting so far? If not, don't worry. We're going to have more interesting topics later on in the course. Okay. Let me know if you find this interesting. You could chime in right now. Does anybody find this interesting? If not, that's okay. Okay, nobody chimed in, so I don't blame you. Okay, the binary system. The traditional binary system is based on powers of 10. The decimal system, I mean, the binary system is based on powers of 2. So here we are, we're going to take a base 10. We're showing base 2 system, a base 10 system. So that's 375, and this is not, again, 1, 2, what I was describing before, that's 8, 10, that's 11, and that's 375, right? So I guess 1 is a 1, 2 is a 0, 4. Okay, so this is confusing. I think they're just going down this way to show you that it's 37. Okay, 1, 2, 4, 8, 16, 32, 40. Okay, so that's what they're showing here. Okay, so they're just showing an example of it. 101, 001. 1 is a 1, 4 that's 5, and 32 that's 37. So they're just doing it down this way. This number down this way. That can be confusing to me. That's what they're doing. Okay. An algorithm for finding the binary representation of a positive integer. Divide the value by 2 and record the remainder. As long as the quotient obtained is not 0, continue to divide the newest quotient by 2 and record the name remainder. Now that the quotient of 0 has been obtained, the binary representation of the original value consists of the remainders listed from right to left. Okay, so I don't have this memorized. Okay, so here they show an example. So finding a figure to obtain the binary of 13. Okay, so we're trying to find 13. Wish they would have wrote 13 instead. Okay. So 2, okay, 2, 13 is 6. 6 is 3. Remainder 0, so as a remainder 1. A remainder 0. 2 divided 3 is 1, remainder 1. 2 divided 1 has a remainder 1. And so that's how they came up with the representation of 13. I think you'd have to be crazy to use this algorithm. Uh, I don't think it's necessary, but I don't think there might be a homework question on. I don't think so. It's easy. You just know by 1, 2, 4, 8, and fill them in. That's how I always did. I never use an algorithm. Okay, the binary addition facts. So the reason why we need to know this is because we may add two numbers together. And so we have the binary representation of one number, the binary representation of another, and we add them together. What is the binary representation? So when you have a zero and a zero, it's zero. When you have a one bit and a zero, it's one. Okay, so either these are these two examples. Now, when you have a one and a one, it's zero and then one. Okay, that makes sense. One and one is two. This is one, two, right? So, okay. So I'm pretty sure we have a, oh, why are we doing this for? Oh, they call the buyer of 1000.01. So 101101 times 1/8, 1/4, 1/2, 124. Okay, we're looking at the 101. So 1/8, 12842. Right? So you gotta go right to left. That's how you did that. 1/8, 1/8, 1/4, and then 101 is simply we know that 124, and that's how they came up with that. Let's see if I'm right about this thing. I think I'm right about that. So you can do the left. They did this a weird way, I think. So it's 2, 4, 8. Right? Because you'll be getting less. As you go to the right, you're getting, it makes sense, right? When you do regular numbers, you have 23.679. The more you go to the right at the decimal, the less, the more the unit. So this would be 2124041/8. Okay, it's just weird how they did this. Hopefully that made sense. If you're still confused on that, let me know. Okay, two's complement notation, the most popular means of representing integer values because we got to represent negative and positives. Excess notation of another representing integer value, two's complement. See, so here they're showing 3, 2, 1, 0, -1, -2, -3, -4 in the bit pattern. Okay, so that's why I sent this out before. Okay, I didn't know. I sometimes I use I like to use the announcements for the simple fact that it emails it to everybody in the course. So make sure you pay attention to email my announcements. Okay, here's a trick to get the bit pattern for -5 for two's complement. So you take 5, which is 0, 0, 1, 0, 1. Invert the bits, so that make it 1010, and then you add one bit to it. And that's how you get -5. That's how I do two's complement, right? So if it's not a negative number, it's the normal way we're used to doing bits from right to left. And if you want to take the negative number of that, then you really said you invert the bits and add one to it, right? So okay. So hopefully that helps. Two's complement. I want to remember that. Okay, here we are. So they're showing a pattern of that, right? So as you can see, the perfect example, 1 is 0001 is the value 1. So if you go to -1, if we inverted everything, it'd be 0, 1, 1, 1, and we add 1 to it, we'd have 1, 1, 1, 1, and that's -1. So you fool around with some of those examples with that cheat sheet that example I gave you, and I'm sure you'll understand it. Using 4 bits. Okay, they're going over this again. I covered this. We can skip over this. Uh, problem in base 10, problem in base 2. Okay, so now they're showing addition. Okay, so 3 is represented 0011. 2 is 0010. So 1 and 0 is a 1. 1 and 1 is a 0. Carry the 1. 0, 0, and 1 is 1. And 0, 0 is 0. And that's 5. Right? 1, 2, 4, 8. And you can check it at the, I mean, let's be honest about it. If someone asked me 3 plus 2, I don't have to do this. I could just go 1, 2, 4, here's 5, 1, 0, 1, 0, right? Negative 3 and -2. Again, they do the same thing. 1, 1, 0, 1. Okay. So if you'll notice that the negative numbers will have a 1 as their most significant, the bit most to the left, which is the most significant bit. If it's a zero, then it's a positive, right? So anything that starts with a one is a negative number. If it's if it's 4-bit size, right? If it's 8-bit size, then the eighth bit is a one or a zero. If the first bit is zero or one. So I think you get the idea, right? The problem of overflow, that's something that we have to be concerned with is if we have 4-bit size and you take if you add the bits and they overflow to the next bit, then you have a problem. There's a limit to the size of values that can be stored. And there's going to be a question about the homework about the overflow. Overflow occurs when a computation produces a value that falls outside the range of the values that can be represented. If the resulting sign bit is incorrect, an overflow has occurred. Okay, that significant bit that I was talking about, the sign bit. 16 bits have been upgraded to 32-bit systems, right? And then we have 64-bit systems and so forth, right? An excessive 8 conversion table. What is this? An excessive 8 conversion. Okay. Of length 3. 1, 2, 3. Value representative. 2, 3, 2, 1, 0, negative 1. Okay, so does that technique also work for, let's say we have 2, 2. Okay, excessive 8 notation. We're not going to get questions for the homework on excessive 8. So in this case, it's the most left bit is 1, and excessive 8, it's positive, and 0, it's negative. Okay, so it's the reverse. Bit patterns of 3. Okay, so you can just construct that, and there's the table for it. Storing fractions, floating point, consists of a sign bit, a mantissa field, and an exponent field. Okay, so here's what they're talking about. There's the sign bit, there's the exponent, and the mantissa. Encoding the value 2 and 5/8. So the left part of the decimal is easy, right? That's just a normal 2. And then 5/8, right? 1001 raw bit pattern. The mantissa 1010. 1010. Okay, so that's mantissa, the exponent. Okay. So I don't think there's many questions on this with the fractions, but that's how they do it. If you have any questions, let me know. Truncate, round off errors, occurs when part of the value being stored is lost. The test is not large enough, right? So non-terminal expressions of fractions happens more often with binary notation. Numerical analysis is the study of dealing with problems when computing large values that require significant accuracy. The order in which values are added can lead to 2 different results, right? So can result in their errors. So data and programming. Okay, so a programming language is a computer system created to allow humans to precisely express algorithms using a higher level of abstraction. I know we have some programmers in the class because I started reading folks' introduction. I know folks are doing Python, which is great. That's a great pro. I know other folks are doing C. I didn't get to read everyone's introduction, but I will this week. Okay, getting started with Python. It's a popular programming language. Here's a print hello world, results in hello world. Here are variables. We're not going to use Python in this course. Analogous to variables in algebra. Think about it. If you had a programming language, you got to store values. You got to have variables. I don't know of a language that doesn't. I could be wrong. And here it says signing hex instead of the give a numerical value, give the hex value. Which is not very. You know where you might see something like this? Maybe if someone's writing malware, a malicious Python script. Then you start seeing crazy stuff like this, like maybe a hexadecimal instead of values, right? And what they're trying to do is they may be trying to avoid detections. So maybe they would look for something. Let's say, I don't know, some stupid reason. Let's say my floating point 26.2 was found in this malware. They might key upon that, but if you have my integer with 0 hex FF, maybe not. Okay, print in here, print 7 does the calculations. Currency conversion, here's an example of a conversion. Here's the sign Unicode value for, so here's the Unicode value, and you can look it up in the table what that is, and it's for whatever that is. I think that's English currency, dollars, and here they're printing out today's dollars, converts to dollars, debugging syntax errors. Okay, like I said, we're not gonna do anything with programming. Data compression, right? That's kind of an important subject in itself, is especially when you're transmitting data. You want to compress it, a zip file, for example, right? When you download stuff on the internet, you usually get a zip file, and then you have to unzip it. It's compressed because that's saving you time to download something, right? Lossy versus lossless, run length encoding. So there's all different kind of algorithms for this. Huffman codes, relative encoding, dictionary encoding, compressing images, right? So compression is also for images. Good for cartoons, JPEG for photographs, right? TIFF good for image archiving. And what the bad guys do is for the images, they embed their malware into the images, the compressed images. They change the bits. Very interesting. Compressing audio and video, of course, then you want to compress that as well, right? High definition television broadcast. Again, you want to compress it so that you can get the data over. It's always the slow part of computing, and it's always been is it's the transmission of the data. No matter what resource you use, it slows it down, right? MP3, that's another way of frequency masking. Communication errors, goal to reduce. Do you want to? Of course, we want to reduce errors, right? We don't want communication errors. Parity bits, they check the bits. They check the bytes. There's something called Hamming distance, which I don't even remember. Okay, so the ASCII codes for letter A and F adjusted for odd parity. Right here's a parity bit. Parity bit is 0, 1, 2, 3. Okay. Has an odd number of, it has an odd number of odd number. So they want to have odd parity. So that bit there would be 0 or 1. The 0 is telling you that there's that these bits would have to uh there could be odd number of bits. It doesn't tell you how many, but there's an odd number, right? And this would tell you if there's a 1 that there's an even number. An error correcting code, A, B, C. So these are codes. Figure 1.27. Is this figure 1? Okay, error correcting code A, B, C, D, E, F, G. So, okay, so we have this coding for these letters. So error code A, pattern received, distance between received pattern and code 2. Because A is 000. We received 0101. So they're which 01 0101. So there is no 010100. So the distance received in code is 2. So that's the distance code different. The difference is the smallest distance is 1. Okay, for D. Okay. Okay, so that's what we have. Some of it is you may be wondering saying, what in the heck are we learning that for? I just think it's important to understand at a high level, understand that there's compression. There might be errors in the transmission of the code. Okay, transmission of the code, but transmission of the bits, and we have to be concerned about that. And there are algorithms and there are methods to deal with that. Okay, so we're done with the lecture, not too bad. And now I want to move on to the homework. Okay, so the homework is and I want to show how I would use ChatGPT. Okay, uh, no, that's my email. Let's see, let's go here. Okay, so content. Let's go to the homework. Okay. Assignment. Assignment 1. Understand how can we present it and stored. Identify hardware to store data. Assignment instructions. Okay, so here are the instructions. So we talked earlier about the gates. So assume that the upper input is 1 and the lower input is 0. So the 0 and a 1. What would the output be when the upper input is 0 and the lower input? Oh, determining. Assume that the upper input is 1 and the lower input is 0. Okay, so you have to put the lower and upper in. What would the output be when the upper is 0 and 1? So what they're saying is do one where it's 0 and 1 and do another one where it's 1 and 0. So there are two cases for each diagram. Okay, so you go through and do that. I think you guys can do fairly well in that. The following table represents the address and contents in hexadecimal
Sorry,
notation.
Professor.
Yes.
Sorry. The first question, I saw some options there. Are we to pick the correct option after we do the one that is 0 and 1 and the one that is 1 and 0?
I'm not quite understanding your question, to be honest with you.
Okay, so I saw some options um after the question. I don't know if the options are like the solution to the question. So maybe
No,
after we've done the question, we can see which option fits.
no. Okay, so this question number 1. Okay, so that's a little confusion. So assume the upper input is 1 and the lower input is 0. So 1 goes here, 0 goes here. And then you go through this diagram and see what the output is. And then you're going to have to do the reverse. This is going to be 0 and that's going to be 1 and see what the result is, right? So for each letter in here, you'll have two answers, right? So they're just
Okay.
changing the input. They're only changing the input. That's all. And so some students are very creative and they actually take this diagram and they put the numbers in. That's great. If you're not artistic, I'm not very artistic. If you just do a table, that's fine too. Okay, so also I notice here it says write down the prompts you use. Cite the literature that you used, if any. Okay, if you use ChatGPT, which I recommend you to do, or could be Claude, any other generative AI. You must write down the prompts you use. You write down the prompts you use. Okay, they want the prompts. They'll say, just copy it. Copy it what you asked it. Okay, and you can even copy in the answer from ChatGPT. And I'm going to show you how to do it in a minute on a problem. Okay. So did that answer your question?
Yes, sir. Thank you.
Okay. Okay. So the following table represents the address and contents, a hexadecimal. Starting with this memory, follow the sequence of instructions. Okay, so move the contents cell whose address is 0x3. So here's the x3 to the cell at address 000. So you take the contents is 0x2 and you move it into address 0 hex 00. So that's the step 1. So you just follow those patterns. Which bit patterns are represented by the following hexadecimal notation? So again, I went over that. You got to convert the letters into bits. You should be able to do that. Okay, so here's a good one. Suppose a digital camera has a storage of 250 megabytes. How many black and white photographs could be stored in the camera if each consisted 500 pixels per row and 500 pixels per column. If each pixel required 1 bit of storage. Well, that's a lot to ask, okay? And I have to admit to you, maybe not that great at math, or like I'm kind of get lost in that question a little bit. So here's what I'm going to use ChatGPT, okay? I think it's very helpful in this. So what you have to when using LLMs, generative AI, you must realize they will spit you out an answer whether it's right or wrong. They call that hallucination, right? Sometimes they hallucinate and give the wrong answer. I think for these type of questions, it should be fine, but you really should read over what it's giving you and make sure you understand it because I think you'll be able to discern whether it makes sense to you. So here's the question I would ask you. All right. So I don't only want the answer, I want an explanation. So storage capacity of the camera is 250 megabytes of storage. So the total storage in bits is this how many bits it can store. Okay, that makes sense to me. Size of one photograph is 2000 over 262,000 pixels. So storage per photograph is 2000 bits per photo. Number of photographs that can be stored. So if you see, if you can see here now, so it explained the answer, and I agree with that. So you can copy and paste this whole thing in. Start from here on the homework and copy the whole thing in. But I said check it, right? You make sure you check it, right? Just make sure that you check it to make sure it makes sense to you. And then copy this whole thing into your homework for that problem. And then you're good. Uh, and that explains what I explained about the in the lecture. Okay. So there's an example of using ChatGPT. Okay, and you could do the same thing with this problem. So encode the following sentences in ASCII. So again, I think you could do this. You could use the ASCII chart, or you could use ChatGPT. If you're struggling with the chart, ask ChatGPT, right? For example. Again, what I want to do, sometimes it's a pain to copy out of these things. Okay, for example, A, right? So this will help you. And I don't mind this because like I said, you're not, I don't see how you're going to use this a lot in your career, but I think you need to master learning how to use a generative AI more than learning how to answer that problem. So I love you to sit here and use generative AI. That's the future of coding, if you ask me, and even malware analysis. It's not only writing code, but it's being very effective and efficient with it. And it's already here. They're using generative AI all over the place to write code. And so use it. I want you to use it. I want you to embrace it, right? And I said, like these basic things, and I'm going to give you a heads up on stuff that I don't think you should use it for. Okay, see, they list each character, and now they went into the you can of course you can go into it found it in the ASCII chart, of course it did, and it did the bits and convert the bits. So understand how to convert 68 to this number. I think you'll understand that. And then here's the final encoded. So again, copy the whole thing out, the question and the answer. And it's great. ASCII uses 1 byte per character. Letters, numbers, and space and punctuation all count as characters. You simply look up ASCII value and write it. So what that does, of course, I bet everybody here could look this up in a binary, could find the binary chart, whether it's in the book, on the internet, whatever. So that's why I like the ChatGPT. Of course, it can do this for you. It can do it really quickly, and you don't spend so much time on this problem. Instead, get to other problems that will require you to think more, right? So again, copy and paste in there. That'd be great to do that, I think. The following code ASCII is byte character in there. What is the message? Okay, again, that'd be one maybe you could put in ChatGPT, I think. That should get that pretty quickly. Convert each of the following base 10 into equivalent twos complement. So maybe you could try one or two yourself, and then use ChatGPT for the rest of them. I don't see a problem there. From each of the following additions of bit strings values, identify each case in which the answer is incorrect because of an overflow, right? So that's where this leading bit, the leading bit changes. So you can do a few of them by hand, and I'd use ChatGPT to do the rest of them, right? So one of the bit patterns and the other one a value stored in XX16 notation, and the other represents the same value stored in twos notation. Uh, what can be determined about this? Now that's a good one to ask ChatGPT about because a lot of people struggle with this question, and ChatGPT can give you some ideas. So when it spits it out to you, make sure you read it, you read it, and then you could ask ChatGPT additional questions based upon what the answer it gave you, right? So let's see this. 1 second. What can be determined about the value? So we put this first one in. All right, and I always ask it to explain. This way you're learning. If you struggle with this, because a lot of people struggle with this. Let's reason out carefully. Two 5-bit patterns. One represents a number in XX16 notation. The other represents the same number in twos, so it's the same number in twos. Signed. Two's complement, negative number. Okay, value 11, two's complement. Unsigned 64, and two's identify the common value. So both represent the same new variable. The common value is -5. Okay, so it's -5. Okay, so that can help you. That's the question. That's it. Sometimes um, I get confused on questions that are being asked me, and I put it in ChatGPT to help me try to answer the question because I'm not even sure what they're asking sometimes, right? And I do this with like I was on an interview for being a malware analyst, and they gave me some malware samples and they asked me some questions that I couldn't even fully understand. So I put it in ChatGPT to help me to reason out what the question was. So it's the same thing here. If you struggle with the question and you're not sure what to answer, go into ChatGPT and have it help you do the answer. And of course, the same as all the rest of them, put your question in, put your answer in. So -5 is the overlap, okay? So here's interesting. So if you want, can I also explain why excessive notation to often mirror each other around zero? Yes. So I like that explained. So here would be, I would love to see this. I would love to see with you new Jet and ChatGPT going beyond the question to learn more. I love that. Okay. Right? So you can go further with them. So I went over the homework. I gave you the presentation. Um, any questions of what I presented or what I went over? Please let me know.
Thank you, Professor. I just have like one quick personal question.
Sure.
So, like, let's say if I'm using ChatGPT for a lot of the questions, right? And I wanted to, is it okay to just do like maybe like a 2, 3 sentence, like in my own words or like my own takeaway from what I understood
Yeah, yeah.
from the ChatGPT, and then like after I do the copy and paste?
Oh, yeah, I would love that.
Okay,
I love that, right? Because now you're learning, right? I care about your learning. So I could use ChatGPT. I would paste in what you did with the work you did with ChatGPT. And then if you want to summarize what you learned from it and what you take away from it, what it gave you, yes, that would be great.
that's perfect. Thank you, Professor.
Yo, you're welcome. Now, I don't want to give you a misrepresentation. Not all of our homework is going to be this way, where we can use ChatGPT for everything. Just happens to be for this first homework. I think it lends itself great to be for ChatGPT. And I think now, with any introduction to computing course, generative AI is becoming such an important tool. I think you've got to have that in this course. And so that's why how I'm doing it. I'm introducing it to try to solve the problems. Now, like I said, what's very important though is just don't copy and paste the answer in from ChatGPT. Read over it, make sure you understand it because it could hallucinate and give you the wrong answer. But like I said, for these questions, I don't think it will. I mean, I've had it hallucinate me on a lot of crazy stuff. Uh, but these are very basic questions, to be honest with you, that it should be able to answer. So that's for this homework. The next homework, when we get into writing assembly code and machine code, I don't really want you to use it. I want you to try to write it yourself because it's a little tricky here with this chat GPT because we simulate it in an 8-bit is it 8 or 16? I think we do this in a 16-bit. A Voltaire is what they call it. It's a simulated computer, and it doesn't really know about Voltaire too well. So I wouldn't trust the answers to that. So when you get to the second homework, we can use it for some of the questions, and I'll give hints on what you can use it for and what you I wouldn't use it for. Okay, and so okay, so that's a very good question. Thank you for your question. Okay, so I don't have anything other to present tonight. I want to welcome you to the course. Hopefully you get off to a great start doing this homework. I think the next homework is the one that the next lecture is the one that folks struggle with assembly and machine code. And but you'll get through it. And so I wish everyone to have a great night and I'm going to watch a little bit of football.
Sorry, Professor.
Yes.
I have a question.
Yes.
Okay, so I just wanted to be sure. Is it the class that is every 2 weeks or the course and the deadlines are every 2 weeks?
Okay, so the course is every other week. To keep up in the course, you should be submitting the assignments every other week. You should be completing the
Okay.
quiz every other week, and what is it? And doing the discussions every other week, right? Get them done. But if you can't get it done for some reason, let's say something you're busy at work, you get married, people get married during the semester, you have a child, who knows? There are many reasons why life gets in the way. I don't deduct for submitting them late. Okay, but try to keep up. Every lecture has an assignment, so try to keep up to complete the assignments and the quizzes and the discussions in 2 weeks. And that's why I don't have
Okay.
dates on them. Does that make sense?
Yes, yes, it does. Thank you.
Oh, you're welcome. Any other questions? Okay, so this was a shorter lecture. Tomorrow, next week's, not next week, the week after the lecture will probably be bit longer. I actually have another lecture from last year that I saved. I'm going to take a look at that. I may ask you also to look at that lecture as well. So it'll be a lot more involved for the in 2 weeks from now. So we're just getting warmed up, getting started. I hope you enjoy the course and hopefully get to know each other. Okay, so take care, everyone. Have a good night.
Thank you.
Take care.